Okay. Hello, everybody. I'm Peter Zhou. I'm the chief scientist of VeChain, and welcome to the 9th episode of VeChain Bootcamp. So, as you have already known that in the past 1 year, our research team has been working together with a team at Oxford University to answer some of the fundamental research questions about blockchain. And today's episode, we're going to talk about our collaboration. So I'm super excited to have invited Dr. Ning Wang, the lead researcher from the team, from the Oxford team. And Dr. Wang is a senior research fellow in data science. So welcome, Dr. Wang. Thank you very much for joining us.
And hi, Dr. Zhou and Dr. Ren. Thanks for the invitation. I'm quite happy to join you on this online event.
Okay. So we also have Dr. Ran here, and he's let me introduce him again. So you might have you may have already know him already. So he is a senior research scientist at VeChain's team, and he has been leading the collaboration from VeChain side. So there will be 3 parts in this episode. So the first part will be Dr. Wang talk about himself, his team, and our collaboration. And next, Dr. Ran is going to talk about AlphaBlock, the latest outcome of our research collaboration. And the last part is the Q&A session. And I have to remind you that don't forget to type your question in the Q&A session. If your question was picked and answered, and you will be given VET tokens worth $20 US. So don't miss that. Okay, so without any delay, let's start the first part. Dr. Wang.
Hi, good afternoon, everyone. Thanks for the invitation from VeChain, and also thanks Dr. Zhou's introductions. My name is Ning Wang. Actually, Dr. Zhou already introduced me. I work in Oxford University. I'm one of the senior data scientists at Oxford Financial Data Lab. So my daily work is dealing with data as a data scientist. I'm also a senior research fellow at Mass Finance Group in Oxford University. So we also we work on a lot of different projects in finance. And I'm also affiliated with the Oxford Internet Institute and also a fellow of St. Hugh's College in Oxford. My research area is deeply driven by some questions in data science, and we want to analyze some wide range of social economic problems by using some data science approach. My research interests broadly lie into a couple of different areas, mainly on fintech, and looking at different technologies. So my main research areas in artificial intelligence, machine learning, deep learning, and recently we are quite interested in blockchains. And actually my history with blockchain starts from 2011 when I was a postdoc in Cambridge University, and I worked with one of the most famous computer scientists, John Comcraft. Professor John is one of the pioneers in distributed systems, and we work together to develop a distributed systems and try to optimize some communication using some approach from social networks and also some data-driven approach. And this work, and still just recently we still pick up this work, and we work with some companies to try to implement some algorithm again and try to use it in blockchain systems as well. And also, we are quite interested in behavioral finance, and we have another professor, Professor Han Qing. He is an expert and mathematician in behavioral finance. And we're looking at a lot of data from people's behavior and try to use some data from behavior to do some predictions. And also my old research area is social networks. So it's one of the key areas that we are working at the moment. So most basically, we are looking at some applications and the data science application like deep learning, machine learning application in finance, and also tradings. And we do a lot of tradings like quantitative finance and also online tradings and social platforms. And we got some students with me working on some social networks like sentiment analysis and use some online sentiment to do some financial predictions, and also looking at some trading behaviors, and also looking at some performance evaluations for different financial products. And recently we work with the blockchain, and it's just start with VeChain, and we starting collaborate like I think 2 years ago, and we were working at different projects. At the moment, we have some breakthrough in terms of some evaluation power framework in consensus. This is we just draft a paper called AlphaBlock. I think Dr. Ren will talk a little bit more about that papers. It's a quite interesting paper. I think at this moment, the blockchain, the core part of blockchain is a consensus, and this is also the bottlenecks, and which kind of limited the throughput for all the blockchain systems. But interestingly, different systems, they have their own consensus protocols. It's quite hard to compare cross platforms. That's kind of initiative purpose we want to do this project, and also we know VeChain have their own consensus protocol POAs, and with all these different consensus, is there any framework we can develop to evaluate and to try to evaluate different kinds of consensus protocols across different platforms? I think this is a very interesting and a key research questions we want to draw from this project. And we also get some collaboration with VeChain and some funding as well. And we recruit postdoc researchers and Dr. Xiang Haitao, and he is the key person working on this project, and he developed this framework together with Dr. Ren. And so this is quite interesting. This is kind of a very preliminary work, and it's still under developing, but we can see it's quite interesting, and we want to do more on this project, and we just submit papers, draft paper to a top conference in blockchain. So hopefully we'll get positive results in December, I think so. And this is one area. Another area is currently we're working at, we're working on token economics. So we know token is a kind of a big ecosystem in all different blockchain systems, and how we're gonna is a kind of mechanism to organize, release, and collect all these different tokens. Kind of very hard questions, and at this time, we don't find any very good papers and research in these areas. And also famously, we know VeChain have the dual systems. We have dual tokens, VAT and VeChain Soul, and how we're gonna define the relationship between these two tokens. And it's quite hard economic problems. It's also some mathematical modeling behind that kind of problems. At this time, we have some initial results at the moment, and I think Professor Han Qing, he is a very, very good mathematician, and he's leading this project. And we also have some researchers working in this area as well. So hopefully, maybe in the near future, we'll have more results in these areas. I think that's very much the introduction from Oxford side. So we'll hand over to Dr. Zhou or maybe Dr. Ren, so you can continue talk more details about our interesting project, AlphaBlock.
Sure. Thank you very much for this comprehensive introduction. And also, I have to mention that Dr. Wang is an expert in the it's a digital currency for the CDBC, right? I noticed Dr. Wang, you has given some lectures to the executives of banks. Would you like to talk something about that?
Yeah, I think if maybe you follow the People's Bank of China, the Central Bank of China, they just released. They are doing some experiment, but in couple of cities they already released maybe the one of the first state-owned digital currency called DCEP. So digital electros and electrical payment. So it's kind of a payment method. And it's not very lot of interesting to talk about, but people, they want to know a lot about what's the story behind that. I've been asked by many banks and to give some talk in terms of why this kind of timelines and what kind of DECPs and gonna impact the whole financial systems, because this is kind of the biggest things probably happen in China and also probably in the world. And but sadly, it's not too much technical details, because all the systems working very much like two-layer systems. The central bank gives the digital money to the commercial bank, and commercial give to the consumers. So two layers, they want to kind of control all the risk, and also, and there's, because this is a separate systems, and there's a lot of consideration constraints whether this kind of a new digital currency will be kind of influence the traditional digital traditional financial systems. So that's why the Central Bank of China, they want to get all the commercial banks and all the old traditional financial systems into this kind of systems. So it's kind of a compromise. You can see a lot of compromise in that kind of. It's not a new thing, not quite exciting. It's not like the Bitcoin, Ethereum, the totally distributed systems, still centralized, controlled by the government, but they just use the blockchain systems and try to help them to facilitate the payment. Because in China, the payments, electric payments, very popular. In 2019, 17% of payments is getting through by mobile phones. So people are getting used to this kind of system. But the biggest part of this payments, the beneficial part, the most beneficial companies from this electrical payment revolution is the big tech companies like Alibaba, Tencent. They dominate like more than 15% of market. And you can see from the Ant Finance, they will do IPO very soon. I just get the permission and they will do IPO. You can see from their reports, the most of revenue from that company is from payments, because the payments now in China is very big. It's trillions of dollars go through payments, and most of this electrical payments goes through the big tech companies. So like all the major banks in China and the traditional payment systems, they not benefit from this kind of systems. That's why they develop this new electrical payment system from central bank. So this kind of a new game. Everyone go back to their starting line and do it again. So it's kind of a competitions, and it's very interesting seeing how this kind of system will develop. I think it's also kind of relate to what we are doing with kind of economic, like all this token economics. And so it's kind of, I think in the future, gonna be a lot of competitions between the major banks and the central banks, and also a lot of private companies like Libras, like Facebook's cryptocurrencies, and also a lot of those small companies have tokens. So it's quite interesting to see, and also it's very new. It just released this month, and we'll happy to see what's happening in future.
Cool. Thank you. It's good to hear all these details and from you, and that's very interesting. All right, so let's move on to talk about AlphaBlock. Dr. Ren, would you like to give us a presentation about this work?
Yeah, sure. Firstly, I'm going to share the slides. Yeah. Okay. I hope everyone can see it. Okay, I'm going to introduce AlphaBlock. As Dr. Wang has already introduced, this is a joint work with Peter and I, together with the University of Oxford, by Dr. Xiang, Dr. Wang, and Professor Jin. So it's an evaluation framework for blockchain consensus algorithm. Well, I have to go very quickly about what blockchain consensus algorithms are. They are, of course, as Dr. Wang already mentioned, they are the very core of blockchain. This is the thing that enables the nodes to reach consensus in an untrusted network. It's basically essentially determines the performance of blockchain. And so so it's very crucial if we want to improve the performance of blockchain. We need to look at the limitations of the blockchain consensus. Well, it determines. Well, you might heard about proof of work, proof of stake, proof of authority, and DPoS. But in the researcher point of view, there are many more blockchain consensus algorithms out there. They can be categorized into two categories. One is called Nakamoto consensus. It's basically the Bitcoin style. People just propose blocks and append their blocks to their locally observed longest chain. And then a block is confirmed after a few blocks appending to it, then the probability of existing of a fork will become negligible. So this is called Nakamoto consensus. It's basically introduced by Bitcoin. And the other one is called BFT, Byzantine fault tolerance. This is a very well-studied project about reaching consensus in an untrusted network. This thing has been proposed and extensively studied before the blockchain era. But after the blockchain era, it has also been very well developed. And this is a different type of consensus. And the question at this moment is that these two kind of algorithms are in general considered as not comparable in the past, because they functions in different type of network assumptions. They functions in different type of security assumptions. They reach different level of consistency. So NC algorithms reaches a probabilistic security or consistency, and BFT has definitive consistency. So in a very rigorous perspective, you cannot compare them. It's comparing apple to oranges. However, the practice is, the reality is, people already use them interchangeably, and we compare them in real life. Well, this is not actually the case if we look back into 3 or 4 years ago, when people consider NC is for public blockchains and BFT is for permissions, well, for consortium blockchains. However, now, as we see, like for example, Algorand and Polkadot use BFT they are public blockchains, but they use BFT. And also some companies, if they want to use blockchain, they simply considers, for example, we want a blockchain consensus algorithm that give us the best throughput, give us the best performance, but they don't really mind whether it is an NC or BFT algorithm or all of these differences behind it. So it is very practical that we need a framework and a tool or a method to compare them. And currently, if you want to really compare, you want to see what consensus, so how good the blockchain consensus algorithm is, the only thing you can do is just to implement them in real life and see how they perform in real life, which is very inefficient. So, and the other thing you can do is look into the technical papers. But in the technical papers, they will say their TPS, but that doesn't tell you too much, because that is the task they made in the laboratory setting, and they always adjust the network assumptions to that favors their algorithm. So their TPS is basically the best their algorithm can have, but it doesn't tell their performance in the practice. So we do this study to answer these two questions. So give us a blockchain consensus algorithm. How would it perform in practice? Or the other way around, give us a practical scenario. What would be the best, most suitable blockchain consensus algorithm that we can use in this particular case? Well, to answer this question, we need to really model in this framework. We need to answer the question, what is practice? So let's look into the practice. For example, what is a network condition? Or let's say, well, to be honest, blockchains are functioning in very good connection and synchronous network. So if we want to know how good blockchain consensus algorithm will work in practice, we only need to look at good connections and synchronous networks. We seldom encounter large network partitions. And if we look at malicious behavior, we don't really need to consider any attacks on consistency because that is a majority attack. But the majority attack, it is possible in practice, but it is outside the scope of any consensus algorithm because consensus algorithm doesn't work if the malicious node controls the majority. So in practice, if they don't control the majority, they wouldn't attack on consistency. The only attack is on liveness. And what is in our opinion, the most worrisome attacks that can happen to a malicious to a blockchain is that the liveness could be affected even by a single node. So basically, we're saying if a blockchain consensus algorithm is vulnerable to 30% of, if 30% of the nodes are colluding and try to attack the liveness, that is okay, because to be honest, all the consensus algorithm will fail if 30% of the nodes went offline or they just trying to jam the network. But it's very worrisome if the network is directly encounters congestion if one node's trying to do that. So the attacks we are trying to prevent is, okay, so for Nakamoto consensus algorithms, the network shouldn't be hindered. The network shouldn't be jammed if one node's trying to create forks. And in BFT, then the consensus shouldn't be hindered if one honest leader could already make a congestion in the network. That case should be prevented. And then the performance, we evaluate the performance by the two key factor, which is throughput, is TPS. I think transaction per second is the most classical index of performance of blockchain. And the other one is latency, the average duration before the confirmation of transactions. And then we put all the consensus algorithm in the very classical blockchain paradigm. Just like Bitcoin, so every fixed amount of time, called a round, a node is selected to propose a block. Okay, and then the only two parameters that can be changed here is block size and block interval. The block size is simply the number of transactions in a block, and then the block interval is a duration of a round. So then the duration of the round, so the block interval should be set such that the malicious node couldn't perform the attack we have just, well, if they perform the attack we have just mentioned, then it wouldn't hinder our consensus process. So this is our constraint on the block interval. So this is generally the idea of our framework. And we consider 4 algorithms. The first one is NC algorithm. It's represented by the proof of authority, but it's not exactly the same as VeChain's proof of authority. It's basically a very highly abstract version of almost all scalable NC algorithms. It's as simple as nodes rounds, while nodes take turns to propose block, and we determines the valid chain by the longest chain rule. We choose this very simple approach because this should, in theory, get the best performance of all scalable NC algorithms. And we choose 3 BFT algorithms representing different periods of BFT development. The first one is PBFT. It's the very classical BFT algorithm before the blockchain era, and it's still being used by many blockchains like Neo. And then the second one is Tendermint. I guess someone of you heard about it. It's the first BFT algorithm designed for blockchain. It's now used by Cosmos. And the third one is Hotstop BFT. It's represents the state-of-art of BFT algorithm, and it's developed proposed 2 years ago, and it's picked up by Libra. Okay, so let's put the algorithm. Let me show you how we consider them in our framework. So this is how a consensus is reached in how NC is reached. So 4 nodes, they take turns. So at around the first node broadcasts his block to all the other nodes. And then after a period of block transmission time, and we also reserve a certain amount of time as the redundancy. And then the dashed line is the end of a round. So this is what happened around in NC algorithm. And NC algorithm will do this for many rounds. So at each round, nodes propose a block, and then at next round, another node propose a block. And after k appending blocks, the first block is confirmed. So how is the throughput and latency considered in NC algorithm? The throughput is simply the size of the block, the number of the transactions divided by the duration of a round, and then the latency of this of NC is the duration of the average number of rounds to have to make k appending blocks. So this is the latency and throughput of NC algorithm. Then the question is, why is it reasonable that we calculate it like this? So in this case, is why the dashes line need to be in here? Why can't it be like earlier? So NC could achieve a better performance. So let's see the case. So firstly, if it is somewhere in here during the block transmission time, so we made the block interval short as the red dotted line, red dashed line. Okay, so it means that the block couldn't be finished transmission in time. It will result in forks in the network. Well, and if we put it in here, what would happen is that at normal, if the block proposer, all the selected nodes of that round is honest, then the block could be finished in time. However, if he is malicious, then he could create fork, and then there is not enough redundancy reserved for the propagation of fork. So what would happen is that in the next round, different nodes might receive different forks, which will result in inconsistency and the degrade of security. So, which means the system is also influenced by a single malicious node. That is also not that is also not good. So we have to make the block interval like this, and we thus calculate the throughput and latency of NC algorithm. And BFT algorithm do it in a very different way. So after the block transmission period, in BFT algorithms like PBFT, so firstly, all nodes, after they receive a block, they send a prepare message, which is the acknowledgement of they receiving the block and agree with the block to every other node. And then, so the first phase is called prepare. And then the second phase is that when a node receives the prepare message from more than 2/3 of the nodes in the network, they will send a commit message to every other node. So this is a commit phase. And after the commit phase, if a node receives the commit message from more than 2/3 of the nodes in the network, he will reach consensus. So he will consider that this block will be agreed by all honest nodes. So at this moment, consensus is reached. This is how PBFT reaches consensus. This is called a two-phase commit process. Okay, so now the red dashed line, if we put the block interval in here, the thing is, if the node is honest, then we guarantee that the block can be confirmed in time. However, the block interval should be larger than this because there is also a view change process. So it means that if the node is not honest, if he's malicious, he can actually intentionally send inconsistent message to all nodes. then during the normal commit phase, no consensus could be reached. So if you put any, well, so the VeChain process is quite complicated. I'm not going into details of that, but the purpose of VeChain is that when the normal consensus is failed, the VeChain guarantees all nodes will be aware of the failure, and then they will tune to the same state to enter the next consensus phase, so they can start a new round of consensus normally. Well, also, if you put the dashed line, so the block interval anywhere in between the second dashed line and the last dashed line, it means that if the node is honest, consensus could be reached. But if the node intentionally to do some harm, then it is possible that the consensus couldn't be reached in time, and then the VeChain couldn't be finished in time. So that then when the next round started, every node could not reach agreement with each other, and then the normal consensus process of the next node will be interfered. So in this case, the throughput of PBFT is basically calculated by the block size divided by the whole duration of the round, and then the confirmation time, so latency of PBFT is simply this whole period. And for Tendermint, Tendermint make some simplification in the VeChain process, so it's similar to PBFT, but then this part, the VeChain part, is shorter. And Hot Stuff BFT made some improvements over traditional BFT algorithm. The first thing is that nodes no longer need to send the message to every other node. They simply use threshold signature and send their votes to the leader, and the leader will aggregate these signatures and broadcast to every node. So it makes this process simplified. And the second process is that they get rid of the VeChain phase by adding a phase, an additional phase in this commitment process. So it's a three-phase commit. One very interesting feature of this Hot Stuff BFT is that the three-phase looks identical. The three-phase looks very similar. So we could use a chained Hot Stuff BFT. So we do it in a chain fashion, which is very similar to NC algorithm. So in each round, nodes first broadcast their block, just like NC, and then all the other nodes will send their votes agreeing this block, but not to the leader, but to the next round leader. And then the next round leader aggregate these signatures and broadcast it together with a new block. So instead of three-phase, now a block is confirmed in 3 rounds, while in NC algorithm it is confirmed in it's confirmed with 2 appending blocks, and with NC algorithm it is confirmed with K appending blocks. And so this is chained Hot Stuff BFT. Well, now we have explained these 4 algorithms, their throughput, how they are calculated. Now let's see what's the result of the comparison. I'll show you this result of with 101 nodes, and when this malicious ratio is 0.3. So the NC, well, we want a high throughput with low latency. It means that with low latency means that the right bottom corner would be the best. So the algorithm that is closest to the right bottom corner is the best algorithm. So as we see that chained Hot Stuff BFT and Tendermint performs well in here, and PBFT is the worst. Well, and NC algorithm, which is quite surprisingly that it is not in such a network, it's actually the surprising thing is that it is actually there is a gap in between NC and HBFT and Tendermint. So, and then we find this gap is actually caused by the forks, because that to deal with the occasionally appeared forks, we need to reserve a lot of bandwidth. We need to reserve make the block interval large so that we can deal with this occasionally forks, and that really hinders the throughput of NC algorithms. So we think, okay, so can we somehow improve the NC algorithm's performance by reduce the chance of forks? So how do we do that in practice? So in practice, in fact, the fork probability is not as large as we evaluated in the last figure, because in practice, in proof of work, it is very hard to make a fork, in fact. And in proof of stakes, there is usually a slashing mechanism. And in our scenario, for example, if you make fork, it's bad for your reputation. And then there is an authority that will vote you in the next election. So that is always some reality, is economical is reasons for you to not make forks. So in fact, the fork probability of Nakamoto consensus algorithm is lower than the one we do in our evaluation. But if we want to reduce the even reduce the fork probability, there is a lesson we can learn from BFT. So BFT reduce multiple rounds of votes uses multiple rounds of votes, so that there's absolutely no fork. So our question is, well, what if we do not do that many rounds of votes because it's costly, and we simply randomly select some nodes in a round and let them vote for the block so that the fork rate could be reduced, and what would that actually give us a better performance? And if you are familiar with this term, it is because this is the mechanism that we introduced in our POA 2.0. Well, this is something look like this. So this is chained hot stuff BFT when every other node responds. And in our case, we use a committee vote. So only select one node, for example, to respond. But it's less complicated, and it should be done in a shorter period. And this is our results. So all the gray dotted lines are the possible achievable throughput and latency pairs. And we can see that the gray points, if we involve the committee, the gray points could outperform. Of course, they have significant advantages over the red dotted line, which is the NC algorithm without committee. But it could also even outperform all the CHBFT and PBFT, and the pink points are the frontier points, and they are achieved by PCE. So if we introduce this committee endorsements, then we can even outperform these two algorithms. This graph gives us a very good insight on this problem, and also good theoretical background for our POA 2.0, showing that, okay, shows us by introducing committee endorsements, we indeed could have a very good performance and significant improvement over the classical NC algorithm without a committee endorsement. Well, that's all for this talk. Thank you very much for listening. And I see already some questions flooding in.
Dr. Zhou, I think you are on mute.
Yeah. Whoops. So yeah, thank you, Dr. for your talk about the AlphaBlock. And now let's enter the last part of our this episode. So please type your questions, and we will pick the questions very soon. I give you maybe a couple of minutes to ask your questions. And remember, if your questions were picked by us, you will be given VET worth $20 US. So just ask your questions, please. We'll be happy to answer that. So let's just wait for 1 minute. Then we can start the Q&A session. Right, so yeah, okay, so let's start. There's a question from David Mashro. Will VeChain be working on a simpler explanation or visualization of these complex concepts to the enterprise community? Typically, enterprise decision makers are not crypto savvy. So anyone of you want to answer this question?
I don't know. I guess
I can't say on behalf of VeChain, but I think the question definitely yes. I think I work with a lot of companies like the bankers, financial institutes. I think you are right, David. Most of the decision makers, they are not technical savvy. They probably they don't have any knowledge in technology. So to get some new technology into the company, especially traditional areas, traditional sectors, and we need very good explanation, visualizations in terms of how this kind of technology, especially for blockchains. Consensus is core part of blockchains, but it's also very technical service, and we need very good explanations. And also, I think that most of decision makers, when they come to the new technologies, the biggest concern is the risk and what kind of risk when they're gonna use this kind of technology. So we need really good studies and research and also explanations. I think this not only for VeChain, it's also for lot of technology-based companies, and we really do that kind of work.
Excellent. So let's move on to the next question, also from David.
Well, I guess we can answer the previous question together with the Marco's question. So can you by any chance explain surface for someone less tech savvy? So I think the thing is, yeah, so I guess this presentation is purely is more technical because this is originated from our technical paper, and we want to present it somewhere in a theoretical crypto conference. But well, sure, I think we will work on more comprehensive explanation of surface and the POA 2.0. And to make it more comprehensive, we should make a tutorial or explanation of surface to the companies and the community, right, Peter?
Sure. Yeah. Can you? So I think we have already published some articles explaining the surface, and yeah, you can find the media articles and then have a read. And I think we have trying to simplify all the concepts and make it readable, understandable by everybody as much as possible. Yeah. So that is where we are trying to do, and we're trying to communicate with our community. So, but if you have any further questions, you can certainly ask the questions, and you can send an email to me or Dr. Ran, and we will be happy to answer all the questions. Right. So So the next question is there a future use case to use VeChain blockchain in government election processes? Also from David. So let me answer this question. So I think we have some voting solutions. We have produced some. We have some voting privacy preserved voting solutions, and I think we have implemented on our testnet, and in a couple of months, I think in future very soon we're building the UI for that, and we're going to roll out the app for community to try, so everybody can try this just this new voting the app to do voting. But I think government election process is a very complex process. It's not just about privacy, not just about blockchain. It also contains a lot of other things. So I hope our voting protocols can be considered in future by the government to be used in any sort of like government election process. Right. So the next question is from Jake Campton. Sorry. So are you able to update us on the status of POA 2.0? Are you able to share any information on when you expect it to be fully implemented? Seems to be a very exciting addition to the protocol. So yeah, I can certainly update you about the status of POA 2.0. So the POA 2.0 is broken into two VIPs, which are VIP 193 and VIP 200. So our technical team, the core dev team, has been working on the implementation of these two VIPs. So I think for the first VIP 193, it will be the implementation will be finished by the end of this year, and we will update our testnet to this VIP. So that's, and for the second VIP 200, it will be implemented hopefully by the second quarter of next year, and it will also put on the testnet. So we will be running these two. So these two VIPs, they are called POA 2.0. So we will be running POA 2.0 on our testnet for testing for a while. Then later on, if we have good results, we fixed most of the bugs, we will propose to move it to the mainnet. And of course, our community have to vote on whether we're going to adopt the POA 2.0 or not. So yeah, that's the latest information about POA 2.0. I hope my answer answers your question. Right, so another question from Jake. Can you share any background on other projects underway with the research? Sure, as Dr. Wang has already mentioned, we're besides the AlphaBlock, besides the framework for evaluating consensus algorithms, we are working on token economics. We are trying to build mathematical model to have a better dual token systems, so that it can lay the foundation for us in future to improve our token economics model. Besides that, we also working on some projects about governance. So it's relatively new research topics like blockchain governance, and we will be looking at that, and we will be working with some we're going to another universities on that, but I can't tell you more details until we fix the make sure the collaboration is going on. Yeah, and also Dr. Ren and I also will be continue to look at look at the blockchain consensus and to see whether any way we can improve our consensus and then make our blockchain more robust and efficient and secure. All right, so I think next question is for Dr. Ren. Can you by any chance explain Surface for someone less tech savvy? It's from Marco Gup.
Wait.
Sorry, which one?
Can you by any chance explain Surface for anyone less tech savvy? I think that's the question for Dr. Ren.
Yeah, but I have first I have already addressed this question in the beginning. I said, well, we will certainly work on that. It will be less technical than this one because this is a technical report, but also I think we once did a very non-technical explanation in one of the previous bootcamp already on Surface, right? So it's basically introduced why we do that and what are the improvements. And if it is necessary, we also have some Medium articles about it. So if it is necessary, we can try to work on a more comprehensive and extensive explanation of Surface in the future and publish on put it into our white paper or the website. I think in the white paper is already quite comprehensive, the explanation. Well,
okay,
that's the answer. Yes.
Right. So another interesting question from CF is that, do you see blockchain as a service platform such as Tencent or Jingdong.com as competition? Dr. Wang, you want to answer this question?
Well, I think all the big internet companies, they have their own blockchain project. In China, I think the biggest competition not from GD and Tencent, Alibaba and Finance, they have very good blockchain team. They made the first online payment transmission from Philippines to Hong Kong. I think that happens like in last year. So, and also we had another big financial group called Ping An. Ping An, they have their very good technical team. They are doing a lot of blockchain research in terms of all this application in finance. But I don't think that's kind of a very competition. So it's competition for real, but different companies, they have their own benefits because all the internet companies, the main business is not in blockchain. For example, Tencent's main business is social networks, gaming industry, and JD and Alibaba, they are e-commerce. And so their main focus is not on blockchain. Blockchain for all the big companies kind of a side product. They definitely are looking at this product, but they not spend the 100% of their resources in blockchain project. Maybe only a slight tiny bit of their resources doing some project. I think this kind of advantage for small companies are not quite big companies and solely for blockchain, like VeChain and like the other blockchain companies. So it's kind of a different, it's kind of competition, but kind of competition in different layers, because the big company, they want to build their platform, they want to do everything. They just want to, build the platforms, everyone can use that. And that's why they make money. But small company, they can focus, like blockchain company, they can focus on technology. So they can focus on their old customers, old business. And that's kind of competition environment. If you think about internet network just happened in 19th. That's exactly what we got at this moment with blockchains. When Apple's and Google, they're very small companies, and at that time we had IBM, we had all these traditional companies. But when these small companies, they can use their technology advantage and do R&D, so get research, and probably in the next round of competition, they can overtake the big company. That's all the, if you're looking at all the technology histories and all the companies, that's happened. So I think definitely the company is not bad things, and it's good things, and we always want some competitions, and that's good for customers, that's good for business, good for everyone. And I think the biggest thing is you need to get your focus, and you need to know what you really want to do and what really you can't do. And once you know the answers, it's just to do your best, and that's the only key ways you can survive from the competitions.
Yeah, that's an excellent answer from Dr. Wang. Also, I want to add a little bit more. So we have an excellent blockchain as a service platform called VeChain. It's the this main product from VeChain. And as Dr. Wang as I totally agree with Dr. Wang, every company has its strength and has its focus. And I think our VeChain's focus will be the enterprise application. So our VeChain platform is built for that, and it is based on a public blockchain. It provides the enterprises the maximum trust it can get from putting their data on the blockchain. And we also made it very easy for enterprises to use the platform to build a blockchain applications. And I think in future we're going to have a session talking about VeChain, and you'll hear more about that. So just yeah. Okay, so that's for that question. So the last question we're going to answer is so how will VeChain use VET in adaptation to usage, in how it applies to the algorithm in the consensus? I don't quite understand this question.
I think probably the question is asking about how the tokens like VT will be applied to the consensus. But I think there's probably two different things. Consensus is the key layers in blockchain try to reach a consensus, which is kind of related to the throughput. And the VAT, all these tokens kind of very high layer. If you look at blockchain systems, underneath the blockchain, we have all these kind of different techniques, like technologies, like consensus, network, and also this kind of very engineering part of blockchain systems. Tokens sitting on top of all this technology part. If you think about the traditional company like Google, the search engine, you have a search engine, it's a very complicated algorithm running underneath that search engines. But and Google is also a public listed company, they have a share price. And this share price is kind of financial market. But if you ask me what's the relationship between the share price and the technology running that search engines, I think there's definitely some relationship, but it's not a direct link. I think you have a better technology like consensus, and you have more customers, more dominance in terms of market. That potentially will influence your price, the share price. I think VAT is kind of a price. It's kind of a public share price tokens for VeChain. Definitely there's some links, but that's not a direct links. And I think we need very sound technologies, consensus, and good throughputs, and we want to reduce the delays and get good throughput for our systems, and also more secure, more efficient. And on top of that, there's more customers and more business, and then probably there's more adoption of VAT, because when people want to use the systems, they need the VAT, and then that's kind of ecosystem how it runs. But it's kind of running on different layers. It's not kind of direct link with each other. I think partly I answered the questions.
Okay, so yeah, that's all about today's bootcamp session. Once again, thanks, Dr. Wang, for joining us today. Thank you very much, and also thank you, Dr. Ren, for your time.
Of course, thank you.
Thank you. Bye-bye.
For joining.
Okay. Bye.
Bye.